Okay, we add a few more details to the scenario. What else do we need to do to project the future climate change? Not predict, project, because we are making lots of assumptions. When you predict, you have a model and you give it some information and of today, and it'll tell you what will happen tomorrow or next year or 10 years later. But when you go to 30 years, 40 years, it's not that simple. You have to say how is everything changing? So population is one of the things, because the number of people matters in terms of total emissions. You have to be careful, remember, because we said rich countries have uh, created most of the emissions, especially because when you look at the accumulated CO2 since industrial revolution, it's been accumulating because of the rich countries. Historically speaking, they are responsible for most of what has already accumulated, but now China and India and Mexico and Brazil and Russia and so on are adding, South Africa, etc., are adding more emissions per year as well. So you have to estimate the population nonetheless, and population projections depend on many assumptions as well. You may be old enough to know that fertility rates, number of kids couples have, each couple has, is dropping, and the good news is, as you educate the girls, they have fewer kids. Okay, but remember, emissions matter. Just because we are fewer people, does that mean emissions will decrease? You have to think about that, because if you have, let's say your parents have only 2 kids, but each of you is consuming or emitting more CO2 than a couple with 4 kids, then we have not done much. Population reduction will help with other things like, reducing the encroachment on the habitats of the tigers and the lions and so on. But without going into too many details, we make some assumptions and project into the future, and we say under some scenario population will hit a peak by about 2050 and will begin to drop. In other cases it will flatten out a little bit later. In the some scenarios it will continue to increase and reach maybe over 12 billion people on the planet by 2100. Now we are about 8 billion, and imagine if we reach more than 12 billion people. That's going to be tremendous pressure. Even if we had all renewable energy, we would still be encroaching on a lot of forests and growing more cities, more people living in the cities, and more people living close to the woods and wildfires, and more people living on the coasts and so on and so forth. So reducing population will help reducing many impacts, even though emissions will still depend on what we do, right? Not just population. And here you expect that the countries want to keep growing economically, and they want to get richer and richer and richer. No country is going to say, I am rich enough now, I don't want any more money. Who's going to say that? Very unlikely. So again, you look at the scenarios and you say how much the purchasing power parity will be. In other words, if you take all the different currencies across the countries and see how much people how much income people have, this is in trillions of US dollars. So let's not worry about the conversion and so on. They have been converted for us, so every country can be compared equally. In general, we think about global population and global GDP because that's easier to track, and there will always be differences in poor countries and low income countries, middle income countries, high income countries, and so on and so forth. Nonetheless, when you do global means, you get a sense of how much global greenhouse gas emissions we are doing and how much impact we are having in terms of the emissions we looked at, the warming we will create, the population, and the GDP growth. So you can see everybody will grow into the future, but some much more, in some scenario much less. Here the population is growing, so maybe that doesn't get very rich. When population drops, maybe you will get rich, and so on and so forth. Okay, but getting rich, does it mean reduced consumption, reduced greenhouse gas emission? No, usually it has meant more and more emissions, but if we increase renewable energy, maybe it will also mean reduced emissions. Okay, so you have to combine all these things together. This looks very complicated, but I want to show it to you, and if you're very young, don't worry about it. If you're old enough, just pay attention and follow up with more. And we are looking at the coordinates here in this direction, going from how difficult it is to reduce our impacts, and here we are looking at another thing called mitigation. What is mitigation? Which is exactly what we've been talking about in terms of reducing emissions and other impacts we have on greenhouse gases and climate change and global warming. Okay, so adaptation is one fundamental aspect which is going in this direction here. Adaptation is easier if we go in this direction and is much more difficult in this direction. So which means adaptation is adjusting to changes that are happening now and will continue to happen as we go from 1980 to 2100, where we look at where we have come so far in 2020 and where we are expecting to go in terms of future scenarios, right? So adaptation means building a seawall or changing your diet and reducing meat because you cannot afford it, or that the production of meat has become too expensive, or you use more efficient I have to be careful about what is mitigation and what is adaptation. Let's say coast sea level is rising and you're getting more and more inundation, then you move away from the coast. That would be an adaptation as well. Okay, mitigation is where we are increasing renewables to reduce emissions, we are increasing forest cover to take up more carbon, and we are consuming less to reduce emissions. We are buying EVs, electric vehicles, to reduce emissions. We are buying efficient appliances like dishwashers and washing machines to reduce emissions, and so on and so forth. If you're old enough, you may think of this as adaptation means managing the unavoidable impacts of climate change that are already happening. Mitigation means it is an effort to try and avoid the unmanageable impacts that may come about. So you have scenarios where we will be sustainable, or we will go here in this case with rapid growth, which means we will not worry about climate change necessarily, even though we may use some technology to reduce emissions. So you are looking at net CO2 emissions, which will reduce in all scenarios, but some will reduce less. You can see this one is not reducing so much. But if you grow rapidly and emit more, you will have a tough time mitigating. You may have enough money to adapt to the changes that come about because you are growing rapidly and emitting more, but reducing emissions by mitigation will be a challenge. Similarly, it's called the middle of the road here, which means you're balancing the challenge of adapting to changes that are happening and mitigating the changes we are making. But here in this direction, you can have a low challenge to mitigation, but you may be reducing emissions at the cost of inequality. Rich people worry about themselves and the poor people have to be on their own. No technology is transferred to the poor people, and poor people are facing the impacts, but the rich people have managed to reduce their impacts. So they have increased the adaptation challenge, let's say for the poor countries, low income developing countries, but mitigation challenges are low here because emissions are low. And here, regional rivalry, these are words used by the models for the future. It just means that we'll have a lot of geopolitical conflicts happening, could be socio-economic conflicts, because remember, with climate change you get damages to crops and sea level rise, which means islands may disappear, or storms may come in and make agriculture impossible, or you cannot live near the coast and do fisheries, or fish have disappeared, and so on and so forth. Heat waves may be killing people. So you may have fights like we had before in the Holocene, where poor countries may send their people into new places seeking refugees, and this can create all sorts of problems because nobody really welcomes refugees in large numbers. Small numbers may be okay. If the numbers get larger, conflicts begin and people don't like other people who are not like them. The tribal mentality may kick in, so you may have a lot of problems. So this is how we are imagining the future in different storylines, different scenarios, different movies. A scary movie maker may say, we will grow, don't worry, and there will be fights everywhere, but we will not worry about mitigation, or we will be paying as much as we can to mitigate, and we will not have much chance adapting. So some people will pay the price, people at the coast will die, and so on and so forth. Okay, so this is in the end gives you emission scenarios and the warming. So depending on which scenario you are looking at, you will get emission to go here with some warming, you will go emission to go negative. Net negative global emissions will give you nice warming that is not very dangerous according to some scientific estimates for the future. This is again 2100. What does it mean, net negative global emission? Which means we'll always be emitting some carbon dioxide and so on, because we'll be growing food and we'll be breathing and we'll be traveling around and flying around, and buildings will be using energy. Energy may be renewable, but we'll still be doing some emissions. But we will be drawing down carbon capture. You don't know what that is. That means there is CO2 in the air, there is CO2 in agricultural production and in emissions of cars and planes, and we will take it out and put it away somewhere in the ground, in the mines and in the ocean, deep in the ocean, and so on and so forth, and make sure it stays out of the atmosphere for a long time, right? Much longer than few centuries, maybe few millennia, few thousand or thousands of years, and that can give us net negative emissions, which means we'll emit some but we'll take out more than we emit. Okay, is this really possible? Not yet, but if you go online and read, if you're old enough, you will see there are some carbon capture machines put up in Iceland and so on, where you have carbon air flowing through a machine and CO2 is being taken out and so on. And there are artificial trees in some places like Singapore, where the air is flowing around and the artificial tree is taking out CO2 just like a real tree that takes out CO2 through photosynthesis. But remember, plants also breathe and release some of that CO2, but as long as they are growing, they are sequestering carbon, or they are capturing carbon from the air through photosynthesis and putting it away, right? So this is how we are imagining the future. We'll come back and continue the discussion on what we are already trying to do to mitigate and adapt. We will not distinguish between mitigation and adaptation, and we are clearly focused on the US in this book because the book is written by an American, but the lessons we learn in this podcast to finish this chapter will be applicable to your place and my place as well. You just have to decide how much you understand, how much you want to follow up on your own, how much you want to ask me, how much you want to ask parents, teachers, siblings, neighbors, and so on. Okay, see you in the next podcast to talk more about what is happening and what could happen in the future and what we are trying to do about these things, remembering that whatever we are doing, the emissions are still not decreasing.